Okay, let's look at break-even point, and this is a really important concept for business owners to understand, and unfortunately I think way too many of them actually don't. And it's just trying to tell us or figure out how many units we have to sell in order to cover our fixed costs and to break even. So if our fixed expenses here are 30,000 units and we have a $4 per unit contribution margin, that tells us that we need to sell 30,000 divided by the $4, 7,500 units. So the basic calculation for figuring break-even point in units is to take the fixed cost, which you saw just a second ago, divided by the contribution margin per unit. So contribution margin per unit. Remember, contribution margin per unit was our sales price per unit minus that variable cost per unit. That is our contribution margin per unit. Oh, it has it there, sorry, I didn't see that. Unit sales price minus the unit variable cost. Then we have the break-even point in dollars. So the above one was telling us how many we needed in units. This one will tell us how much we need to sell in terms of dollars. So take your fixed cost divided by your contribution margin ratio. And that's contribution margin per unit, which we just had, divided by the unit selling price. Okay, so here's an example. ABC company sells XYZ at $5 per unit. If fixed costs are $200,000 and variable costs are $3 per unit, how many units must be sold to break even? So you may want to pause and see if you can figure that out before going on. So remember our formula. It's going to be fixed costs divided by the unit contribution margin. Well, fixed costs are $200,000 and the unit contribution is the $5 sales price minus the variable cost of $3. That's $2. So that tells us we need to sell 100,000 units. Well, now the next question then becomes how many dollars worth of sales do we need to sell in order to break even? This time we have to calculate that unit contribution and margin again, which is $2, but we have to take it a step further and calculate the contribution margin ratio. So we take that $2 unit contribution margin divided by the sales price per unit of $5, so that's 40 cent or 40%, I guess it should say. And then we divide that by the total cost. So we take the total cost of 200,000 divided by the 0.4 or 40%, and that tells us that we need to sell 500,000 units. Now we can take that a step further because most business owners don't just want to break even. They actually want to make money, which is where that cost volume profit analysis comes into play. So we can take the same formulas and just add this desired income to our fixed costs. So fixed cost plus desired income divided by contribution margin unit per unit will tell us how many sales we need to break even plus make the desired profit. Or we can do the same to determine how much we need to sell in dollars. Fixed cost plus the desired income divided by contribution margin ratio. And we can graph that as well. Some people like to see it visually. So you can see here we have our total fixed expenses, and then we have our total variable expenses above that, and those do vary depending on volume. And that break-even point is where our total expenses intersect our revenues. And then any profit will be over and above where our revenues exceed our total expenses. So depending on how high we get on desired profit is where we want to go. Okay, and we did have those assumptions. I'll just remind you of those for CVP analysis. We're saying that we're operating within the relevant range. Unit sales price is going to remain constant, as is the unit variable cost and the total fixed costs. And our production will equal our sales. Okay, so to figure out what a company needs to make, we would take or to figure out what our income will be, we'll take our income minus or equal to our sales, minus variable costs, minus fixed costs. So here's an example there. Rydell expects to sell 1,500 units at $100 each next month, so that will be my sales right there. Then fixed costs are $24,000 per month. and the unit variable cost is $70. Well, we know we're going to sell 1,500 units at $70, so that becomes my variable cost minus the fixed cost. So my income will be $21,000. Now we had those formulas, again, that we could use to calculate the target or desired income. So let's put those into practice. If ABC sells product XYZ at $5 per unit, if fixed costs are $200,000 and variable costs are $3 per unit, how many units must be sold to earn income of $40,000? So the exact same problem we had a minute ago, only now we want to earn a $40,000 profit. So we need to take our fixed costs of $200,000, add the $40,000 in desired profit, and that will give us $240,000. Then we need that contribution margin per unit, which was $2. 240 divided by 2 says we need to sell 120,000 units, and there's your ratio right there as well. Last topic here, we'll talk about margin of safety. So this tells us how much sales can drop before the company will start incurring a loss. And margin of safety can be expressed as a percentage of expected sales. And here we take the expected sales minus the break-even sales divided by the expected sales. And that will give us a margin of safety percentage. So if Rydell's sales are $100,000 and break-even sales are $80,000, what's the margin of safety in dollars and as a percentage? Okay, well, expected sales are $100,000, break-even is $80,000, so that's going to be $20,000. And then we take that $20,000 divided by the $100,000 expected sales. So we have a 20% margin of safety here, or $20,000. You can also take that a little bit further. And this is very similar. So it says compute the margin of safety ratio. If the margin of safety in dollars is $250,000, actual or expected sales are $750,000, the margin of safety ratio is 33%. And here's the important part of this slide. So it says the higher the dollars or the percentage, the greater the margin of safety. So if Marshall Company had actual sales of $600,000 when break-even sales were $420,000, what's the margin of safety ratio? Okay, well, let's figure that out. We need the margin of safety dollars divided by the actual expected sales. So we see the answer is 30%, but how did we get there? Well, margin of safety in dollars, take the $600,000 minus the $420,000. That gives us $180,000 margin of safety in dollars. Divide that by, again, the total sales or expected sales of $600,000. If we do that, we should get 0.3 or 30%.